Okay, welcome to Slack Math's take here on an introduction to the domain and range of a function. So there's so many ways to approach this and such a broad topic, but we're just going to look at a couple of the elements of the definitions of domain and range and function and kind of apply them here. These should match up with the practice problems that you're asked to do on Slack Math that correlate to this. So anyway, let's just start with here a quick little word problem. So Sally sells lemonade for 10 cents a glass. So if she sells no lemonade, right, she doesn't make any money. So her revenue, so we'll say this is glasses. How many glasses of lemonade does she sell? And this is the revenue. If she sells one glass, she has 10 cents. 2 glasses, 20 cents. 3 glasses, 30 cents. And so on. So what is the domain? The domain of this function is 0, 1, 2, 3. These are how many glasses she could sell. Now we're making some assumptions. She's not going to sell half glasses or 3/4 full glasses. She's not going to sell negative glasses of lemonade. So basically the whole numbers is the domain. Now the range, well, this is going to be 0, 10, 30, and so on. You can write as a set of elements here as the domain and a set as the range. You can also write the ordered pairs of the function itself. So that can be 0, 0, 1, 10, 2, 20, and so on. But a lot of times what you want to do, and like they're asking us to do in this problem, is to find a formula to express. So you can write this as, let's say it's a revenue formula. Revenue in terms of the number of glasses sold. So if she sells one glass, she gets 10 cents. So this revenue is 10 times G, the number of glasses. That gives you R. R of G, in this case, is in cents. Here's a totally different kind of question, but it's still involving domain and range. So the function f of x equals the square root of x. So what is the domain? Well, I can take the square root of 0, I get 0. I can take the square root of 1, I get 1. I can take the square root of 9, I get 3. I can take the square root of 25, I get 5. All of those I can take square roots of. I can take the square root of 20, but geez, when I do that, square root of 20, I get an approximate value in my calculator, 4.47. Not an exact value, it's irrational. However, it's still a number. So it's possible to take the square root of 20. But if I try to take the square root of a negative number, like the square root of negative 16, take the square root. So it says domain error on my calculator anyway, and you may get similar error messages. This is not possible. Not when we consider the real numbers. So what does that mean? Well, the domain could be basically, the domain would be all positive real numbers. Or you could say x is greater than or equal to 0 is another way to write it. Now the range is actually the same thing, because no matter what we do when we take the square root, we're always going to get a positive real number. Except when we take the square root of 0, in which case it's 0. So positive reals and x equals 0. Positive reals and y equals 0. The range would be y is greater than or equal to 0. There are other ways to look at this one with graphs and things, and I think the further you go along in your algebra studies of functions, you'll have other ways to look at this problem. Finally, normally here, if a function is defined as y equals 3x plus 1, where the domain consists only of these values, what does this function look like? So I like to make tables, so helps me understand what's happening sometimes. So if I put negative 3 into this function, I have 3 times negative 3 is negative 9, plus 1 is negative 8. If I put 0 in, 3 times 0 is 0, plus 1 is 1. If I put 4 in, that's 3 times 4 is 12, plus 1 is 13. And that's really all I'm allowed to do because that's the only elements in the domain. So this function as a set of ordered pairs. So it says, what does this function look like? One way to look at it is ordered pairs. Another way to look at it is, well, what if you graphed it? And this is obviously not to scale. Negative 3, negative 8. Here's one of the elements in the function, one of the ordered pairs. 0, 1, be like right here. 4, 13, be like up there. Oops, that's the 13. 4, 13. So you have these three. Now, if you were to connect them, they actually do form, they are all part of the same line. But for this function, we're only looking at these three. Therefore, the function itself is just those 3 points. I don't draw the line there in this case. And that's just a quick introduction to domain and range of a function.